My name is Andrew Coble, and this is my Project 6 presentation for CE 570. In this project, we were assigned with defining a deformation map for the 3D body, calculating tangent vectors on the undeformed body, calculating the deformation gradient of the map, defining 3D curves on the body, and then verifying the deformed length for one of the curves. On the left-hand side, you can see the vector field that's defined, and then also the deformation map, as well as the map that I had in my code. All right, so on this slide, we're going to walk through the tangent vectors of my undeformed 3D body, starting out with the first piece, which is the hemisphere. Here's the definition of that body. Here is the tangent vector with respect to r, the tangent vector with respect to phi, and then tangent vector with respect to theta. My second body is a cylinder, and here's the definition of that body. And then here's the tangent vector with respect to r, tangent vector with respect to theta, and then tangent vector with respect to z. Finally is my third piece, which is the upright cone, and then this is the definition of that body. And this is the tangent vector with respect to r, theta, and z. And then on the right-hand side, we have the definitions in my MATLAB code of the tangent vectors, and the first one is my hemisphere, second one is the cylinder, and third is my cylinder. In this slide, we're going to walk through my deformation map and then also my deformation gradient. So as you can see up here, we have the deformation gradient of my hemisphere, the deformation gradient of my cylinder, and the deformation gradient of the upright cone. And then here is the generic piece of the map, and then also the deformation gradient solved out. All right, so in this slide, we're going to go through the curves that I defined on my body and then also the deformed body. So starting out with the hemisphere, we have a curve defined around the exterior radius, which is 4r. Going around the outside of the body. And then for the cylinder, we have one going around. It's also 4r, but it's on the bottom part of the cylinder. And then we have our newly defined curve, which is just a vertical curve with radius 4r fixed going up the side of the cylinder from 9h to 10h. And then finally, we have a curve going around the exterior of the cone, which is at radius 3r. And then as you can see here, this is the deformed piece of the deformed curve. In this slide, we're going to walk through that deformed curve that I referenced on the last slide. Here is the parameterization of that undeformed curve with running from 9h to 10h, and then the length is found to just be 2 because it's just the height. And then here is, I basically plugged that parameterization into the map, and then I found the tangent vector, and then I normalized it and integrated it to find the length, which came out to be 2.6383, which matches the value I found in MATLAB. All right, so in this slide, I'm just going to walk through some of these values. So first off, we have this tangent vector for the hemisphere, and then moving down, we have the defined map for the hemisphere, and then also the deformation gradient for that map. Moving down, we have the tangent vector for the cylinder, and then we also have the map and the deformation gradient for the cylinder. Then we also have the tangent vector for the upright cone, as well as the map and the deformation gradient for the cone. And then finally, we have just the generic map here on the bottom. And then I'll push run on the code. It's going to take a minute to load. All right, so as this loads, it should generate us our snow cone. All right, so as you can see, we have our tensor field over here on the left, and that's the undeformed cone, and then on the right, we also have our cone with the tensor field and our deformed curve on the right-hand side.